Circles are one of life's natural shapes. As Ralph Waldo Emerson once said, the eye is the first circle, the horizon which it forms is the second, and throughout nature this primary figure is repeated without end. So it's pretty natural, that when we're talking about things in, well, any context more than just math, circles do tend to appear quite often. They're very popular as metaphors. For quite a few different types of things.
Someone once told me time is a flat circle. Everything we've ever done or will do, we're going to do over and over and over again.
And if we want to talk about circles in the specific context of the plane here, of what we've been talking about, really all they are a basic application of the distance formula. So if you start from the origin, you start from the very middle, and what you want to do is describe the set of points that have some given distance. So you have some point xy that is r units away. Well, you have your center, you have that point, and you know that the distance using the formula is r is equal to the square root of x squared plus y squared. Very, very basic. And then if you square it, you get r squared equals x squared plus y squared, which you should know is the equation of a circle centered at the origin. But what you can think of that as doing is you take that value r and you spin it all the way around the circle to get every single possibility there, to get everything that you could possibly want for that circle, because it describes all things of the same distance from the center in terms of the radius. Where if you want to think more generally, think about any circle centered at any point hk, it's basically the same thing, where you're talking about distance instead of just being from that central point. So h and k are 0, you are subtracting h, so you're getting h units away from x in a sense, y units away from k in a sense, to get r squared equals x minus h squared plus y minus k squared, for exactly the same reason as what we were talking about in the beginning of this section. So again, when you think circles, just think points that have the same defined distance. And we're going to finish this section here with a couple of quick examples for how these constructions work. So for one example, we want to write the standard form equation of the circle with center 6, 0, and radius 5. Very, very basic formula work here. We have that our center is 6, 0. So we have that 6 is h and 0 is k, while our, oh, that's a weird A. Our radius in this case is given as the value 5. So plugging those into that formula, we're going to end up with r squared, so 5 squared, is equal to x minus h. Oh, this should be specific here because we know what h is in this case. I don't need to write that there. That just looks weird. H is 6, so we have x minus 6 squared plus y minus 0, because 0 is k, squared, or if we want to simplify a little bit, and usually we do, 25 is equal to x minus 6 squared plus y squared. Again, formula manipulations, be careful with where those constants go. You'll end up where you end up. So let's get one more quick example here that has a tiny bit more where we're looking at graphing something like this. So for our very last example of the unit, we want to graph the circle given by the equation x plus 3 squared plus y minus 1 squared is equal to 4. So again, it's a matter of understanding what we have. Because we're given that form x plus 3, that means h is equal to negative 3, because remember standard is x minus h. And then k, y minus 1, k is 1. So we have center negative 3, 1. And because we have a 4 on the other side, take the square root of that to get to r is 2. And if we want to graph that, it's pretty easy. You just graph your circle like so, get a picture like so, and that's it for this unit. So, good luck getting ready for our first exam. I'll see you back here next week. We're going to be moving into chapter 3, talking about some functions that have maybe a little bit more to them than what we've started with here so far. I'll see you then in a little bit.